water splitting. So within this sunlight absorptions, it is going to be required, which is going to strike the photoanode. It excites the electrons within this, and based on this, the semiconductor material they are going to have, so creating a electrode hole pair, and the water splitting reaction takes place with excited electrons are then used to catalyze the water splitting reaction at a photoanode, where the water molecules are oxidized to produce a hydrogen uh, and oxygen over here, and some purification is going to require over here. Some another process we are going to have, that is here, that is high temperature uh, water splitting, where the high temperature which is going to be attained by means of solar radiation, and the this is the work has been taken from the Chu et al. Over here, and they have published this in a chemical in a engineering journal. And another method, they we have the hydrogen production from the biomass over here. Next process, we have the hydrogen production through nuclear power. Within this hydrogen production from nuclear power, if we are going to talk about, uh, so nuclear reactor can produce high temperature heat over here within this. So in order to harness this heat over here, a high temperature electrolysis can able to be performed over here, or a thermochemical hydrogen production can going to be attained by means of this. So nuclear heat, that is the nuclear reactor, generate a significant amount of heat during the operation at a very high temperature reactor, and this heat generated heat can be used to high temperature electrolysis system, or to produce a thermal chemical hydrogen production over here. And the hydrogen production at a high temperature, water gets split into hydrogen and oxygen using this heat energy. And the high temperature drives the chemical reaction in order to release the heat. And some gas separation techniques are going to be used in order to collect it separately, and the generated hydrogen is having the purity of more than 95% over here. Another one, we have the hydrogen production from the solid oxide electrolysis over here. The structure, if you are going to talk about, it consists of a solid electrolyte which is sandwiched between the two electrode, anode and cathode. The solid electrolyte is typically made up of ceramic material, that is Zetrite stabilized zirconia and Standardite stabilized zirconia, that is SC, SZ and YSZ. This electrolysis mode within this external power is going to be supplied in form of DC, and applied across this SOEC, and the electrical energy initially two separate electrochemical reaction takes place over here at the anode and cathode, where the reduction and oxidation reaction takes place, and based on that the hydrogen is going to be formed in form of overall cell reaction. Here the reactions are mentioned over here, and the gas separation, where the hydrogen is going to be collected at the anode side, and while the oxygen is going to be collected at the ca- oxygen at the anode side, and hydrogen at the cathode side. Both are these gases are going to be separated in order to avoid the mixing. And the purity level, if we are going to talk about, it is having a highest purity level of more than 89% over here. Now some challenges associated with this, that is the storage. Here we have covered the hydrogen production part over here. Now it comes that how we are going to store the hydrogen over here. So the storage of hydrogen is typically made by means of different methods over here. So some methods I have illustrated over here. That is the physical method and material based method. Within the physical method, we require the compressed gas and cryogenic compressors we are going to require. And in terms of phase change, if we are going to talk about, we required it to convert into liquid where through liquefaction, and liquid hydrogen we are going to take about. But in terms of material, we are going to talk about that. It can be used as an absorbent over here. That is MOF. That is here some where the hydrogen is going to be accessible by means of surface. Within that material, the hydrogen is going to be absorbed at the surface in itself. Then next one is the BN methyl cyclopentane, which is in a liquid organic form through which we are going to store it. Next is the interstitial hydrides over here, which is made up of lanthanum nickel hydride, where the hydrogen is going to be stored, and some other form, that is the complex hydrides, are also going to be used. And lastly, we have the chemical hydrogen over here. So these are some typical methods which are going to be used for the hydrogen storage. If we're going to talk about the interstitial hydride, certain metals like palladium or can absorb the hydrogen atom into their gaps, interstitial sites, we can going to call it out, on their crystal lattice. And the working principle relies on the formation of a metal hydride, where the hydrogen atoms are integrated with the metal atomic structure to release the hydrogen, and the metal hydride is heated and exposed to a low pressure, causing the hydrogen atom to dissolve from the metal lattice over here. Whereas in case of this complex hydride, if we are going to talk about the sodium borohydride, that is NaBH4, they generally used over here, containing the hydrogen combined with another element. So its working principle involves the chemical reaction where the hydrogen is either released or absorbed from the compound under specific conditions. So catalyst and temperature change can facilitate this going to be a reaction. Another approach, if you are going to talk about in terms of liquid organic, this liquid organic is also sometimes called it as a liquid organic hydrogen carrier, LOHC, and these are organic compound are can reversibly absorb and release the hydrogen through catalytic reaction. So its working principle involves the center of chemical bonding, where the hydrogen is going to chemically bonded to this LOHC, that is the liquid organic hydrogen carrier molecule, when storing, and release process involves the breaking of chemical bond under the specific condition, which aid with an catalyst over here. So these are related to catalyst. This methods are very expensive, and right now some alternative catalyst in order to find it out still is under going on. Next, in terms of absorbent, if we are going to talk about, that is the cryogenic liquid, if we are going to talk about, for that, I'm going to show you that part. Yeah, here within this, that is compressed hydrogen and the cryo-cooled compressed hydrogen. So it is a hybrid method where the hydrogen rich is first cooled to a cryogenic temperature, uh, and then it is going to be compressed. So it combines the benefit of both cryogenic storage as well as the compression. And cooling this gas reduces its volume, and it make it easy to compress and store at a high pressure. So this approach provides an efficient way to store the hydrogen uh, at a high density over here. Next approach, if we are going to talk about related to this, that is the cold and cold, I have already compressed one, that hydrogen is typically compressed at a high pressure in a storage tank, and which is a straightforward method. For this, significant amount of energy is going to be required for packing the hydrogen molecule closely together under high pressure. So when it is needed, high pressure hydrogen is going to be released and used in various applications, just like as a fuel vehicle in the fuel cell technology over here. And in terms of cryogenic, if we are going to talk about, the temperature is minus 253 degrees centigrade over here. So it's quite challenging over here. In terms of liquid hydrogen, if we are going to talk about, it is one of the easiest method for the transportation over here, where the liquid based, this is an asymmetric structure over here, that in which the this can be transported over here, where the cryogenic compression is going to be required over. So these are the containers where the liquid hydrogen is going to be transported by converting in a liquid form over here. And then another method, we have the material based, that is the hydrogen storage and absorption over here. That is the absorbent method. I have already told that they are going to be absorbed in their metal lattice over here, that is in the crystal form over here, and it is going to be released when it is going to be required, then in a liquid organic hydrogen carrier, where the liquid cooling LOHC is going to be used over here, then in form of interstitial hydride methods, where the lithium, nickel and other things, these hydrogen molecule are going to be trapped within this lattice structure over here. And then next we have the complex hydride, which is having a significant application over here, that sodium borohydrides are going to be used over here at a temperature of around 180 degree centigrade, and this is going to be stored in this form over here. You can see it over here. Then hydrogen, chemical hydrogen storage, which is one of the last method. Within this, hydrogen is going to be stored within the chemical compound such as ammonia, and its working principle hinges within a reversible chemical reaction that allows the release and absorption of hydrogen from this compound, and the catalysts to change in temperature and pressure are going to use to drive this reaction over here. So in summary, I'm going to talk about this hydrogen storage method employs various physical and chemical mechanism to store and release the hydrogen for different application over here. So for different application, this method requires the specific infrastructure over here. So for different application, the choice of method depends upon the various factor, that what type of energy density it is going to be required, then safety, efficiency, and sustainability for a specific use cases are generally going to be required for this. So here I just going to end my session. So thank you. We may have queries over here from the participants.
Dr. Saab, I think in one of the PPT by one any of the experts I had seen earlier, having discussion regarding the amount of energy required per kg of hydrogen produced. In case of your SOEC, I think for the electrolysis purpose, the amount of energy, if you have in these slides available or either the data remembered in your mind, then please tell me per kg of hydrogen, what is the amount of, as you have just in last line discussed about the energy density. So if it is available data, then you please may show what is the amount of energy we are supposed to give for the electrolysis purpose. And per
In
kg
terms of
hydrogen,
temperature, I'm going to talk about, sir, or in terms of megajoule you are asking, sir?
pardon?
In terms of temperature, you are asking for SOEC?
No, no, sir. Actually, yeah, in case of SOEC, as you said, the energy is required for
Okay,
electrolysis purpose.
okay. Electrolysis purpose you are asking, sir?
Yeah, yeah, yes, sir. For electrolysis purpose, amount of energy is required, right?
Okay,
To
for that,
supplement.
generally for that high temperature is going to be required, and in terms of electrical energy, that around 234 4 or 240 kilojoule per mole of hydrogen is going to be required, or in terms of total energy in terms of heat, around 290 kilojoule per mole of hydrogen is going to be required. So ultimately, in terms of electrical energy, 200 to around 300 kilojoule of mole it is going to be required.
And as we produce hydrogen from there, and from 1 kg of hydrogen produced, how much energy we are having, because it may facilitate us for the transportation purpose when we are running our bikes and motorcycles and everything. At that particular time, the amount of energy needed, and that can be if it is being served by the hydrogen, then because if we are producing energy to supplement this process, that is the electrolysis, and that energy is not renewable, then it is of the loss.
Yeah, yeah.
This process will not
High
be as a.
temperature is only been possible if you are going to have a high temperature application, just like a gas turbine and other thing
Yes, yes.
for aircraft application over here. Or even in if in the automobile field, if you are going to talk about where some other methods and techniques through which we can reach such a high temperature over here, so that enough significant thermal energy if we are able to supply thermal energy in terms of 10 to 30 kilowatt per hour per kg of hydrogen. For that type of thermal energy is going to be required. And in terms of electrical energy, if we are going to talk about, 35 to 45 kilowatt hour of kg of hydrogen is going to be required. So that type of energy is going to be supplied for SOEC practical application here.
So amount of energy we give, and amount of energy as an hydrogen we obtain. So if it is not matching,
No,
then
no, no, sir. Definitely it will going to match because if we talk about the calorific value of hydrogen, it is in terms of megajoule if we are going to have. And for initiate such type of reaction, we required in the kilowatt part over here. So related to technological aspect, that technology has already been demonstrated in terms of SOEC. So in terms of direct electricity, pure electricity, it is going to be required for that one, that in terms of heat in order to have the chemical reaction across the anode and cathode. So
yes.
for that some waste heat energy applications we can use it for that part.
Yeah, yeah. Right. Matlab where the energy is easily available, either
Yeah,
from
yeah,
the
yes, sir.
renewable sources and okay, okay, sir. Thank you, thank you. Lot of thanks for your this special. Actually, unfortunately I missed your first day presentation. Now, that's why I
No issue, sir.
eagerly asking for this.
Actually, we have given the experts from IITs and NITs, but due to their some engagement over here with their director here, in this short period, they have just informed that it's very unfortunate that I have other commitments related to this with the competent authority. So therefore, I have given that session. Right now, today itself also that previously it was one given by Dr. Tapan Gogoi, which is from the one of the leading researchers from the Tezpur University. But unfortunately, due to having health issues, he have to rush to hospital over here. In the morning itself, around 7:30, he have called me and informed that it's Dr. Saab, it's very unpleasant to have inform you that I am having the medical issue or concern and I have to rush to hospital. So therefore, it's very difficult for me. If you insist, I will try to give it in the second half. Then I just inform him, no, no, sir. First of all, take care of your health part. It's very important. And immediately he rushed to hospital. And then me and Aman has decided to take up this session over here.
Even Jan hai to jahan hai, as said
Yeah,
by the Modi.
that's the very very important
Correct.
thing, sir. As a
But
faculty
even
member, this is our part, but as a first thing comes our health over here. So it's very important.
but even Amanji has given a very nice presentation of the another software which was easily
Yeah, yeah,
available.
yeah.
So I appreciate and fantastically you have managed this session. This is really appreciable from your part.
No,
Really,
no,
sir.
thank you, sir. At last moment, it has only been possible by means of some significant supports from our research scholar. And here, one of my first research scholar is going to take the next session. That is Dr. Abhinav Anand Sinha. And
Yes.
maybe in the next half, he will going to take the session. And at last, my guru, that is my PhD under Dr. Sanjay, is going to take the last session over here. And before that, I think we are running late over here. Our next speaker is Aradhya Tiwari. She will going to enlighten you related to the application of AI ML in this direction of how to use it in the energy aspect over here for the sustainable future over here. So she will going to take this next session over here. Aradhya, are you there?
Uh, Thank you, Tushar sir. Let me introduce Aradhya ma'am first. Uh, our next speaker is Miss Aradhya Tiwari. She is currently a research scholar at IIIT Jabalpur. She is passionate in AI and data science educator with extensive experience in machine learning, AI model training, and data-driven application development. She has previously worked as a coding, math, and data science instructor, teaching global students and mentoring learners in national level hackathon and competitions. Today, she will present through the practical machine learning lab sessions based on environmental dataset analysis. So I welcome you, Miss Aradhya Tiwari, and now it's over to you, Aradhya ma'am.
Yes, we are having Mrs. Aradhya Tiwari in this FDP, and she will be going to deliver a talk on the use of artificial intelligence and machine learning in air quality. So it is very insightful presentation. It would be going to be because nowadays we usually hear about AI and ML, which is means doing a great job on, it is being researched at a vast scale, broad scale, and in every area you can find the application of artificial intelligence and machine learning. So with her deep expertise on AI ML, because she has also working means experience of working in various academic industries. So I welcome Mrs. Aradhya Tiwari to deliver her lecture on the use of AI and ML for air quality index. So now it's over to you, Mrs. Aradhya.
Am I audible?
Yes.
Yeah. Thank you so much, Yugal sir and Dr. Aman, for introducing me to everyone. Good morning, everyone. I am Aradhya Tiwari, and I am here to take the lab session on air quality analysis by using machine learning model, which will basically help us in understanding how we can apply machine learning concepts in the field of research based on sustainable energies. Now, before I begin the session, I would like to thank Dr. Tushar Chaudhary for inviting me to present my work in this FTC. I'm truly grateful for this opportunity. Let me share my screen. Right. So today we're going to discuss about the air quality analysis by using machine learning model. I hope my screen is visible. Okay. So talking about the air quality index, it is usually measured on how clean or polluted the air is. It helps determine the health effects of air quality. We face a lot of issues in like that are related to the respiratory problems and ENT infections, and there are major risks for heart disease and lung diseases that are happening today. As we can see, many cities are affected by the pollution, the air. Thus, these are the major pollutants: the carbon monoxide, benzene, ozone, nitrogen oxides, and nitrogen dioxide. You can go through this information. You can either take a screenshot and read it later. These all gases in the environment, they do affect the air quality index. Along with these, there are some non-methane hydrocarbons, which, except for methane, these are collectively called non-methane hydrocarbons, and they do cause a significant impact on the climate change and human health. Yeah. And when analyzing the air quality index trend, the temperature and the relative humidity cannot be ignored. The temperature controls how pollutants move and and react in the air, while humidity influences how particulate matter forms and stays suspended. Therefore, comparing these two parameters provides deeper insight into pollution behavior and improves the accuracy of the air quality prediction model. You can see here in my data set, the data set that I will be taking, we'll be working on studying the temperature influence on the air quality index with respect to the relative humidity influence. Now let's talk about the machine learning model. What is exactly machine learning, first of all? Machine learning is just a part of artificial intelligence which enables the computers to learn patterns from data and make decisions or predictions without needing explicit programming logic. Now, the key idea is that the model improves automatically when exposed to more data. Just like human beings, if I give you a book to read on a particular topic, you will have information on that. But if I give you 10 books on that same topic, you will have more information. You will be more experienced on that to understand things better in that particular line. The same thing happens with the machine as well. Now, just like in human beings, this is something natural process going on. But here in machines, it's not natural, it's a man-made thing that we call it artificial intelligence. That's the only difference here. Just like humans learn from experience, same goes with the machine learning. Machine learning is used everywhere today, right? From predicting pollution levels that we're going to do today to diagnosing diseases that I am doing in my research area. We can also use it in detecting frauds in bank or analyzing any scam that's going on, or recommending content on YouTube and Netflix that we see every day. Now, in this session, we'll see how machine learning helps us to analyze real world data sets scientifically. First of all, there are two terms which are very important: the types of machine learning, supervised and unsupervised. So let me tell you, supervised learning uses labeled data to train the model. We include input features and a labeled output so the model knows what the correct answer looks like during the training. It's just like how we teach the students that if you or any kids, like when you're incorporating any daily habit into them, you say that if you do this, something good will happen, and this is the good thing that will happen. Like if you study better, these are the marks that you're going to get. So this is supervised learning. Person knows what they will do, so what exact results they're going to expect. We use it here for classification or regression tasks, for example, like predicting air quality category from pollutant values. And then comes the unsupervised learning. Here we work with unlabeled data. The model tries to discover hidden patterns or clusters on its own. For example, if you are roaming around in a playground and you have no idea about what that place is like, what are the dangers there if an insect is crawling or there's the grass is too sharp to might cut your skin. So these are like unlabeled data. You have no idea what is going around here. You experience based is based on the random situation that occurs, and then you get an idea that okay, these are the dangers, and we can list them under these categories. So it happens later. Earlier, there is no labeled data given to you. Over here, the model tries to discover hidden patterns and clusters. For example, we can group cities based on the similarity in air quality trend. Like, for example, if a city is polluted due to maybe there are many industries over there, there are factories that are giving out fumes, so that city might be affected due to that case. Or in a city, there are so many vehicles. There are no factories here, no industry, but there are so many vehicles here. So these are two different scenarios. But we are studying the same thing, air quality analysis. Now you see how the same study can be grouped into two different types. One is the supervised learning. The one we are going to do today will be the supervised learning, because here we have a list of various gases present in the air, and we have temperature, relative humidity, absolute humidity, all these data we're going to work on. But in unsupervised learning, we're not sure exactly what is causing this. We have to read the data further in different manner. Okay, so here is the research workflow in machine learning. First of all, we define the research problem. What exactly is the case we are working on? Next, we collect and study the data set to understand what each feature means. Just like I told you in the previous example of walking in a playground, where you analyze, where you come across different sort of dangers. So you can list them separately in a column. And here also the same thing is going on. When we analyzed the air quality, we came across a set of gases that were present in various quantity in various places. So this is how we gathered the data and listed them into different categories, different features that we call it. Now comes the pre-processing. Once you collect the data, it's not always clean and exact and exactly ready, like which you can work on. You have to prepare it. There are missing values. There are null values. There are some garbage values. Suppose the person who was collecting, they didn't get the exact value. So they just, to fill up that missing place, they entered any garbage value. So you have to clean the data. We will discuss this in the coding part later today. Finally, when we have selected a suitable machine learning model based on the type of the problem, we train the model on the part of data and test it on the remaining data to validate the performance. Finally, we evaluate the results, interpret what they mean, and document the findings for publication or reporting. Now, let's see how exactly this works. So first of all, the data is organized into structured rows and columns. It depends on where exactly your features are listed, either in the rows or columns. Usually, the columns are the features. And from these columns, one or two, or depends on what kind of data you're working, we select one or two columns as the target variable. Now, most data sets, the rows represent individual observations, while the columns represent a measurable variables or features. Now, in our air quality data set, features may include the various gases that I discussed in the beginning. Then there's temperature and absolute and relative humidity. The target variable is what we want the model to predict. Now, in this case, we're going to predict the value of relative humidity based on the feature that is the temperature. How is the temperature changing and how is that affecting the relative humidity? And before we build any model, we always check the shape of the data set. That's very much important. Shape of the data set tells you how big is the model, how many observations you have, how many features and targets you have, just the number of rows and columns, that's it. Then the summary statistics, missing values, data types, etc. Okay, this is going to be the flow of the code that we will be doing today. First of all, we begin by importing the necessary Python libraries such as Pandas, NumPy, Matplotlib, scikit-learn. Later on, we will also be using sklearn ensemble, as we will be using random forest classifier today. That is the machine learning model. We'll discuss this later. Then we'll learn which help with data handling, visualizing, and modeling. Then we'll load the data set and display its structure using the functions like head, which displays a list of observations from the beginning. Info, which gives you the information about the data set, what different types of values are there, whether it is a string, float, or number. That is what it says. Then describe. So describe basically tells you what kind of data you're using. Next, we pre-process the data, handling the missing values, encoding text values, scaling features, and selecting important columns. Finally, we split the data set into training and test set. This is the most interesting part of this, where we train our machine learning model and then evaluate its performance. Finally, we interpret the results using the accuracy, confusion matrix, and classification report matrix. All right, I will demonstrate the complete workflow live in Google Colab using the air quality data set. So let's dive into that now. Just a minute. All right, I hope you can see the Colab screen. Someone can confirm. All right, so to save time, since we have well less time, I have already prepared the stage, you can say. What we're going to do, I'll just quickly walk you through this. This is the Colab platform, this Google Colab notebook where we can work with Python code. It has an online in Python IDE that you can just write your code. You do not need to download Python or any of its packages or libraries into your system. Thus, in today's meeting, I've been using this. Okay, so here, first of all, we are importing the necessary modules and loading the dataset. I have used the dataset just for the sake of explaining all how it works. I have used this dataset from the UCIML repository. So for that, I have to install this package. We have to write exclamation point pip. That pip is Python install Python install UCIML repo. And when I run the code, it can run it from here. This gets installed. Next, I'm going to import a few libraries and modules. So first of all, the data set that we're using, load the data set here to basically call it from its repository. We have to use UCI ML repo import fetch underscore UCI repo. And then any data set that we work on, it is basically like an Excel spreadsheet of rows and columns. We call it data frame in Python. And to work on these data frames, we use pandas. And it's just a short form of it, pandas as PD, so that I don't have to write pandas everywhere in the code. I can just write PD and call any of the function of this particular module. Next, before fetching the data set, it automatically completes the code to save time. I'm going to import NumPy, which will help me to read the columns as a list. It basically helps to read the data in the form of arrays. That is why we use NumPy. Then we have matplotlib.pyplot as PLT. It helps you to create the graphical figures. Same is the purpose of Seaborn as SNS, but the only difference is it is even more visually attractive, you could say, and has a little more functions than that. Okay, so let's see all our data. So I am going to put that into the variable air quality data set equals to fetch and equal the same function that we called earlier. Fetch underscore UCI repo will call a particular data set from its repository. All the data sets are listed with their particular IDs in this repository. I'm going to write ID 360 here, which will call the air quality data set that we are going to work on today. Next, okay, you can see I have written this really big name of variable, and if I have to use it, it will waste a lot of time again. So I can do one thing, I can put this entire variable into an even smaller one. I'll just call it df. So df is air quality dataset dot data dot original, which calls the original dataset and stores it in df with all its properties. Okay, next. Now you obviously want to see what this data looks like. So I'm going to write here df.info in the beginning, not yet. Info, and as I run the code, okay, this you can see the output. This is how the data is. There are these many columns. Date, time, we have CO, PT, OA.H1, NMFC, the benzene. These are all the gases we discussed. Ozone, NO2, everything. These are the gases that are present in this analysis that we are going to study now. Then apart from this, we have the temperature, relative humidity, and absolute humidity. We will be working on this, the temperature part. And along with that, we will be seeing how does that affect the relative humidity. Next, we'll just quickly, I'll show you how the data set looks like. So for that, I can run the function df.head. This displays the data set. Okay, here you have the data set. You can see, okay, there is a catch in this head function. Head function can be used to see the top 5 values, the top 5 in the list of any data frame or anything you call it on. By default, it will show you the top 5, like from 0 to 4. These are the top 5 in the list it's showing. I can also write here 10. And so it will show me the top 10 in the list, and you can work with. All right. So here you can see the data set. I have the date, time, all these values written here for the level of presence in the air for these particular gases. And we have the temperature, relative humidity, and humidity. All right. Now, as you can see, this data is good. There's no problem with this data, but still, when we were reading this data on an Excel sheet, the CSV form of it, they have mentioned the NaN values. So for that purpose, we had to clean this data further, which takes a lot of time. It's like you can say trial and error method when you do it for the first time, because you're new to the data. You have no idea what's going on in that. So you have to go through the data, go through each and every value, make sure that your data is perfect, even though it is saying that there are null values, but you don't know there might be. Now here I have this date time column, which I separated it to have a separate column of months, because I want to see later on like how the temperature is changing in every month. What is the air quality in each month? whether it is in summer or winters, obviously it changes. So here I have created separate date and time columns. This itself is the pre-processing of the data. Before working on the data, before applying your machine learning model on it, you process the data. Sorry, you pre-process it, you clean it, and you see. So first of all, let's quickly go through this. There is no one way of doing this. Depends on which data you're working on. So first of all, in the date time string series, I've made a variable here where I am separating the date, space, this is a space, and time. And then I'm testing that it will be a string type. The string is read as just characters of numbers and alphabets put together. And I am explaining that replace the dot. There was this dot over there in the beginning where date and time. So I have replaced that with the colon. This is the standard way in which we write or mention the date anywhere. Next, we are converting the datetime objects in a particular format of day, month, and year. Here, by using the format option, in the pandas module itself, we have a to_datetime function that we can use to do this. Okay, I'll quickly skim through this. This is nothing. We are just dropping the rows where there is nothing written. There are some rows where the time is mentioned as NAT, not a time. The person or whomsoever collected the data, they might have not mentioned the time specifically. They just wrote a null value. But you can see there is a value written NAT. There is still something written. That is why the info table in the beginning will not read it as a blank value. It will read that yes, something is mentioned there. That is where we need to pre-process the data. We cannot just take this info as the final saying that yes, the data is correct and we can work on it. Here is where it comes handy. So in dd.series, I'm using this not any function which removes such values and the drop any function which updates the data set after dropping the rows that we do not require, which have these NaN or NAT values. Now we have we are extracting the year, month, and day from that DT series. DT series is I have changed this date time into one value from which I'm reading the date, the year, the month separately so that I can create a separate column for these four. These are the four columns I've created: year, month, day, and day name. And now I'm just putting it back into the data set. So now this is my final data set. You can see I have one column for date time like it was earlier. And here I have four more columns: year, month, day, and day name. Now this will help us to read it further, categorize it further. Suppose I want to see that maybe on Sundays everyone goes out to enjoy, or maybe there are less people who roam around because there is a holiday, so people don't go at work. So maybe the people can study it like that. Okay, now coming on to what we are supposed to do today. We will be visualizing the monthly values for temperature later on using this categorization that I've done just now. Before that, we will be studying the temperature and relative humidity. So for this, we will start by binning the RH into categories. You can see here the RH values are given in this manner, but we will change these values into low, medium, and high, which will help us to understand it better that whether the relative humidity is high or low based on the temperature values. So for that, first of all, we use the bins variable. I just created this variable here in this. We'll call the data frame. I'm calling the data frame column rh.min. So the minimum values first, which are ranging from 14, 7, and then 14, 17, finally, max. Okay, so what we are doing here is I have given these 3 to 4 bins to it, the minimum value, then the values around 40, 70, and the maximum values. And then I have created 3 labels: low, medium, and high. Rate is still completing. Alright. So now I'm in the data set, I am creating this new column here, RH class. RH class where in the same from the same column the same column RH will be replaced by the pins and labels. These will be the labels. It will categorize all the data from the RH values, the values mentioned in this column, into these 3 bins labeled as low, medium, and high. So all the values present in this column, 63, 73, these you're seeing this now, these will change to low, medium, high, depending on which bin they lie in. If they lie from the minimum to 40, the minimum value to 40. If they will be inside the low category, they will be replaced with the word low. If they lie between 40 to 70, they will be replaced by the word medium. And if they lie between 70 to max, then they will be replaced by high. So this way we will get 3 values in the RH column based on what were the previous values there. Now, yes, include lowest equals to true means we are keeping all the values here. Now, next, I won't run this right now. You can see this. Oh, okay, if you want, you can just see this. df.head. You can see the output, so you'll get an idea, and later on we'll continue from. Okay, here you can see the RH column. Now here in the RH class, we have medium, like for these values, it's showing medium. Maybe if I write 10, I'll get more. Okay, in the beginning, I think there are medium values. But yes, so you understood, you got the idea based on these values. You can see it's a 40, 50, it's ranging from 40 to 70, these values. So for that, it has entered medium here as a new column, based on the RH column we had earlier. All right, I'll just replace it right now, and we can work on further here. Okay, now here we start with our machine learning part. Now, in this, we have 2 parts, features and the target. So features, we call it as X. We put it in the X variable. I'm putting it as DF. From the DF column, this also I need to put within square brackets. We use the square brackets to call any item inside the array. And since we are using a data frame itself is like an array of arrays, you can say. So that's why I am first of all calling something from the data set. I'm going to use the square bracket. Now from that array of data set, I'm going to call a particular column. So that itself needs to be inside the square bracket again. Now, y equals to the RH cube. Sorry. Y equals to the RH class, and in this RH class, I'm going to drop any, what if there is any count. After this, I'm going to import the modules from sklearn. This is a machine learning module. You can call it here, not this one. First of all, I'm going to call random forest classifier. We use random forest classifier because it helps us to read this categorical data easily. There are many other modules available, such as the XGBoost classifier and many which you can use. But currently, I'm using here the random forest classifier. It also depends on what kind of machine learning you're trying. Are you trying with the regression part or the classification part? Here in this, we have the supervised data. I'm sorry, we are doing the supervised machine learning. We have all labeled data that we are using this one for the classification. Library I'm going to call sklearn metrics. Going to import classification report and a confusion matrix. Then from the same sklearn, I'll explain you what this is later. Model selection, going to import the train test split. All right, so these you can say that these are the ingredients of the recipe we're going to make today. First of all, we're going to use the random forest classifier machine learning model. Once we apply it on our data set, it will tell us what's the accuracy, precision, other such parameters for this data. Then we'll have a confusion matrix which actually tells us what went into this model, how many true values we're getting, how many false negative values, and all that. Train test split is going to do the process of splitting the data into training set and test set. Let's see how this is done. So now let's do the split. So, okay, you can see this. We have two variables here, xtrain and xtest. This is the first part. Like we have this entire data as 100% of it, and part of that we will put into the training part. So with that, we'll have the features that went for the training and features that were kept to be tested later, where we're testing the model. So for that, we're securing some features. Then similarly for the target, the targets that were the part of the data set that was sent for training, the target part, and the part that was secured to be tested later, to test the model later. Now here we use the train test split function where the first value we give is x, that is the temperature column, then y, which is your features. So temperature will be your feature, y will be your target, the RH class. Next, we're giving here the test size. This is very important and quite interesting too. Like here, you have to give a decimal to 100, and that is the percentage you're giving for the test size of the data set. So, for example, if I write 0.2, so 0.2 into 100 gives you 20% of data set you are securing for the test, and the remaining 80% is being taken to train the model. So the data set, you have a data set of more than 9,000 values, 9,000 observations. So from that data set, you are giving 80% to train the model. What are the features? So what should be the target? What should be the values here? How you're you're just telling the model that, see, for this value, you're supposed to give out this particular result. This is how you're training the data. With the 80% data, you're feeding into the model. And once your model is ready, you will have 20% of data to check whether the model actually worked perfectly how we expected it to or not. So this we are going to state. You can write any state here. Suppose I write 42. So what you're going to do, this is I have this notebook here. I have this entire code here. I can come to edit the code, change it, add something to it, and I can work on it as many times as I want. I will every time run this code cell again and again and again. And as you know, we are randomly assigning the part of the data set for training and testing purpose. I am not telling the computer to use suppose rows use the rows 1, 2, 3, and 4 for training and 5 in that manner. I'm not saying that. I'm telling it to randomly select 80% of the rows. Any rows it will select. And then I'm saying that whatever is remaining, that will obviously be 20%. That will be the test size. How do you see your model to be selecting different rows again and again? Because if it will select the same if it will select random rows again and again, I will get random results. Like maybe the rows that I sent into the data set were different the previous time, and now they are different. So now my model is behaving differently. I'm not sure whether I've used the correct model or not. Thus, we fix it to a random state 42. So every time I run this code, every time, today, tomorrow, whenever I come back to this notebook, I run it again and again. Every time it will select only those specific rows to train the model, and the remaining specific remaining rows, I can continue my work in the same state. I do not that, okay, yesterday the model was giving me a different reading, now it is giving me different. So we kind of fix it to the random state 42. You can write any number here, but just make sure you do not change this in any day you're working on this code. Till the time you want your model to behave differently and take different rows, that you can do. Okay. Now comes the main part where we are making the when we are using this random forest classifier. So I have used this CLF. I'm using this CLF variable. It's a classification, I think, with any name here. It's not that. This is how I'm going to write it. Random forest classifier. I'm going to give 100 estimators. This estimators are estimating the data, how the model will read the data. And here also you can see I'm using random state 42. So this, okay, these two also have nothing to do in common. I'm just using random state here for selecting the data size separately. And here I'm using random state 42 for the random forest classifier to read the data in a particular manner every time I come back to it. Okay. Now CLF.fit. Here I am, so fit is basically like you're putting the values of like you're training the model, so how it will fit into your data set. How the data set will fit into the model. So I'm feeding the training data set here, X train and Y train. Based on this, it will predict. Let predict using the predict function, and inside this I will put the X test values. Remember, I made an X test here to test the model. That is what I'm doing here. So I will put this X test here and the values. So the model will predict based on these values in the X test. It will predict what outcomes do I get, and those will be stored as a list in YPRED. So we have y test here, and here I'm creating a new variable y pred. So these are the values that the models predicted for the test. Finally, let's see how the model works. So I'm going to use the print function here, which can print the value of any function, variable, model, whatever you function which we called earlier. Okay. So here in the classification code, yeah, all right, nothing else. So here, first of all, I'm going to print the classification report that will compare the y test and y pred. Y test is the actual value that was supposed to be the output for the model, and y pred is the value that the model predicted. Obviously, this is what you're going to do, how you will match the values to see that whether the model is giving the correct result or not. And finally, we're going to make this confusion matrix. I will explain you this after you see the output of it. Let's run the code and see how our model is working. Disconnected. Oh, I'm sorry, I used the wrong word here. This is ensemble. Okay, fine. I'm sorry for that error. Okay, here we have the values for precision, recall, F1 is score, and support. And there, can you see we have the three values that we clubbed our data into. We have high, low, and medium values for RH. So for the high, it was up to 33% of precision, low was 80%, and medium is 68%, you can say. Accuracy is up to 69%. This is how we can check our model that up to 69% of accuracy it was able to predict the data. Here is the confusion matrix. These are the true positive values, true negative, absolute positive, we can see. And finally, let's, in this manner, it might get confusing if you're reading it for the first time. I will just do one thing. I will create a graph here that will help you visualize how it works. Again, I'm using data frame. And inside this data frame, this is data frame is a function of pandas module where you can just enter the data frame you want to visualize. You're just grouping it into two columns. Here I have, okay, I do not want this thing auto completed it. First, I'm going to have a temperature value that we will take from the X test. Then we have the actual RH. And then the predicted RH. So these are the, this is how I'm creating a new data frame here using Pandas module where I will have three columns: temperature, actual RH, and predicted RH. This is what we want to visualize right now. The temperature will have the values in X test, since that is what we want to visualize. In the test data set, all the values for temperature. Then the two columns for actual RH, those are the Y test values, and the predicted RH, the values that were predicted by the model for these test values. Next, obviously I'm going to use df.plot underscore filtered function here, since we also want to remove any extra values that we do not want. And also in our data set, there are so many values for the that are in the like. Okay, I'll do one thing. I will just create a plot first of all, so you'll be able to see how it works, and then I'll explain it to you how it works. So df.plot, and inside this I'm going to call df underscore plot from the same data frame that we created earlier, and I'm going to create a plot between temperature that is greater than equal to 0. Since we have most of the values in our data set are above 0 to 50. So thus you will be able to visualize it in that part better. From 0 to 50. And so here I have created a plot from where temperature is greater than or equal to 0 and less than or equal to 50. Between these 2 points, creating the plot. I don't know why it's showing over here. Okay, please tell me for this. Now I'm going to make df plot filtered equals to df. This will be helpful to mention the values. Right? The values by temperature. So it will arrange all the values in a sequential manner by the temperature column. So we have 3 columns here: temperature, actual RH, predict RH. It will take this column, and based on this, from low to high, it will arrange all the values in a particular sequence. So this is why we use the sort values function. So that's why we are getting all these error lines. Now it is gone. Now let's plot the figure. So this is a PLT. If you remember, we use the matplotlib.pyplot as PLT module. We called it earlier. From that PLT module, I'm calling the figure function. Inside the figure function, I'm giving the fig size. Fig size is the size of the graph that will be visible to us, and by 6. You write 12,6. Next, we have to write here the SNS. Remember, I told you that this gives us even more visually attractive brush with more functions as compared to the matplotlib pyplot. That's why I'm using this Seaborn here. SNS dot line plot. Inside that, I'll have 2 axes, x-axis and y-axis. The x-axis will be temperature. The y-axis will be actual RH. Now, I have just told it to take temperature and actual RH on the x-axis and y-axis respectively. How will it know where is it coming from? So for that, we have another attribute, that's data. Inside the data, we write here the data, which is this is basically what you need to write here, but along with this, so, like I have the data, I have the x-axis and y-axis. That's done. It will give you a simple graph based on what you can see. But along with this, I will give it one more attribute of label, which will write over there what is the label we are putting here. That is actual RH. So you can see what this particular graph will do. And the same thing I have done for predicted RH, because we want to compare two values. We want to see how the output is appearing. So the model has predicted this. I'm going to do this. Now, by default, it has taken color as blue for the actual RH, and predicted RH, it says taken the color as red. You can also put another value here, which is the marker. Okay, there are basically symbols like 0, star, or dash line, or you can use any here. You can either put a small O, or you can put a cap, or you can put a star. Any sort of marker you can take. I'll take a small O for the actual RH and marker X for the predicted RH. Finally, we have PLT.X label that will show us the temperature. And to be more specific, I'll write here C. So that will be helpful to understand that, okay, it's showing us the temperature in Celsius. Next, a relative humidity value, because this is exactly what we're predicting here. So that I'll put in percentage. All the percentage values are mentioned at the time. This is the label of our x-axis. This is the label of the y-axis in x label and y label. This label, actual RH, is for the plot of this particular line that will be drawn on the graph. This label, predicted RH, is for the line that will be drawn for the predicted RH. So there will be two lines, two plots on the same plots. Finally, PLT.Legend, because we want to see the legend. So much just a second. Come on. All right, here you can see the output. It looks a bit too confusing, but I'll explain you what this is. If I would have explained you from this classification report, you might have understood it a bit up to some extent. Here, this is even more clear to see. You can see jumping all over. This is the actual values of RH, the Y test values that were sent to the model, that were kept to check whether the model is predicting correctly or not. And the orange line that you can see, that is what the model has predicted. You can see where it is overlapping and going around along with the blue line, and you can see whether it is completely apart from what it should be. So let's start from here. The first one, you can see it is almost overlapping. You can see for some values, the blue and orange lines are overlapping each other. They're going together. But for some values, like for here, you can see the blue is predicting low. Sorry, the blue is, the actual value is saying that the humidity is low, but the predicted value says that humidity is high. So here is where we see some difference. And okay, here we have a lot of difference here. You can see the blue lines are all over. And but still some places it is doing. So we can say that 69% here, the accuracy as that was listed, 69% is able to predict well. Maybe there are some values if we give more data to it, or if the data set is bigger, we create more samples, feed it better. So maybe it will able to predict even better, or we can also use some other classification here, some other machine learning model. But this is how it works. It helps you to understand the data better. It helps you to understand the research that you're working on. So here I'm working on the air quality analysis. Learning model, how I can use it to feed the data for the temperature and even other columns. You can even group all the gases together and then see what kind of values you're getting for the temperature or humidity, how it is affecting that. So this was it. You can work on any model like this, but the main part, the actual thing that you need to understand is this one particular line, how you need to split the data, how we need to select the test size, and based on that, based on your data set, which particular classification, which machine learning model you're going to use. That's all. Thank you so much for giving me this opportunity to explain my expertise here. If you have any such any questions regarding the session, you can ask.
Thank you, ma'am.
Thank you. If any participant have any doubt, so you can ask or in the chat box.
Thank you, Dr. Ajit. I can see your message. Thank you so much. Thank you, Dr.
Okay, so there is
Okay.
no question. So
Is there anyone have any doubt? Any question regarding this? Please ask, or you can write it in chat box.
Right. Yes, please write it in chat box. I am able to see the message. Thank you for appreciating.
Thank you everyone for today's session. We will meet at 2 p.m. For the next session, which will be delivered by Dr. Abhinav Anand Sinha, sir. So we will be meet at 2 p.m. Thank you.